Welcome to our webinar. We're hosting a series of webinars, Project Health and Safety Services, in partnership with Moura Lawson in Qatar and UAV 365. The webinars we're going to be focusing on over the next couple of months will be basically safety and technology, how we can use technology to improve our health and safety practices on the ground. Today we're going to be concentrating on the use of drones in safety. And our little strap line here, how an eye in the sky will benefit the feet on the ground. And we will be keen to get your views shared by question and answer. Use the chat box provided. And also, if you want to follow up by email, please feel free to do so. So today's speakers, Iain Hyslop, Managing Director of Project Health and Safety Services, myself, David Lamont, and Ben Williams from UAV 365. We've been working with Ben for a number of months now, talking about how we will use drones in a safety context, their application from a technical perspective, what sectors they can operate successfully in, and where the challenges and constraints may be. And as we go through the webinar today, we'll be talking about some of these issues. So the main areas that we're going to cover today will be drones and the technology itself. So we'll be asking Ben to talk us through, how drones have come on in the last couple of years, where some of the main constraints and some of the main issues currently are, what technology might suit sectors specifically, and some of the challenges we have perhaps around connectivity, internet connection, etc., etc. So we'll go through all those issues and unpack all of that as we develop the webinar. Iain Hyslop will talk us through where we see the benefits that some sectors can get from drone technology. Some of them are quite obvious. We're then going to break the webinar down into two parts. One will be some of the technical issues around external survey inspections, the capability of a drone working externally, and how they can be used in practice. And then as technology has moved on with the drones, how internal survey inspections have now come into the fore, and some of the drones that are specifically designed for working within those environments. And some quite interesting footage again that Ben will talk us through as to how drones can be used very much within a kind of confined space environment. I'll then be speaking about our kind of vision for how we see remote health and safety inspections working with drones. We've got a number of potential clients that we want to be working with in this arena, and I just want to just talk that through. And again, we'd be keen to hear from yourselves through the chat box and also by email on your views, and indeed whether you would be interested in piloting a potential project using drones. And then we'll talk a little bit about how the difference between live link-up or recorded footage might work in practice. Direct live footage obviously gives it a dynamism and a potential to save quite significant sums of money rather than having people on the ground necessarily. What we can do is provide 365 24/7 cover through live link up. Where that's not possible, then obviously we'll talk about the difference between that and recorded footage. So I'm now going to pass to Ben Williams, who will take us through drones and the technology as it is today. And then I'll pass back to myself and we'll have a further conversation with Iain Hyslop on the sectors. Ben.
Thanks, David. Thank you for the introduction. So I'm going to talk about the advancements in drone technology that have allowed us to do some of the things we can do today. And from that, you'll get an understanding of where those advancements will lead in terms of improving their performance as time goes on. So the primarily improvements in onboard sensor technology, but also flight time, ruggedization, and autonomy have led to the application of drone technology in an increasing array of sectors. Primarily advances in miniaturization of high resolution RGB sensors or traditional visual cameras, as well as other sensor technology such as LiDAR, multispectral, and thermal imaging, has led to the opportunity to use drones to gather inspection grade visual data in otherwise hard to reach locations. In almost all applications, drone technology presents a cost-effective risk mitigation tool. Repeatable flight plans enable you to track change or progression over time with no room for error. For example, you could have an area of your site surveyed regularly without any risk of skipping something during a scheduled inspection, for example. Rapid deployment on site reduces any local downtime and removes the cost associated with high access or confined space access, such as mobile platform provision or scaffolding. And of course, the main reason to use a drone is to access hard to reach areas without risking personnel. So how do drones increase safety? Deploying a drone in an area with, for example, earth moving plant on site removes the need for personnel interaction with that plant. The drone operator and their assistant can be located on the site perimeter in a clearly marked area and can carry out all their inspection works from a safe distance. In addition, the gathered visual data can be shared across project teams via cloud-based delivery, so there's no need for personnel to travel to site, and this ensures that all team members receive the same up-to-date information. Another key safety aspect, of course, is avoiding the risk of at-height working, which is essential on any site. And clearly, drones can access height areas in external environments, but also, as David mentioned, thanks to innovation in the drone sector, there are now options for internal at-height inspection as well, done safely. Using a drone to increase your understanding of maintenance issues, for example, allows detailed planning before sending a team into a high-risk area, saving time, increasing safety, and allowing cost-effective preemptive maintenance. How do drones increase accuracy? High-resolution sensors and image stabilization deliver detailed visual data, and when combined with repeatable flight plans and survey software, it is possible to autonomously scan and record a site with no room for error. You can track changes on the ground by flying a regular site survey, and the process data can be shared and annotated across your project team via the cloud. What makes drone use cost-effective? Reduced inspection or survey costs, with no need for complex access equipment, with the associated costs and logistical challenges that come with getting such equipment to site. A drone operator can deploy on site within a few minutes, and many survey flights require less than an hour of flight time. And in most cases, the site does not need to shut down during this time. This rapid deployment reduces disruption and allows live site flow information to be gathered, giving an accurate picture of health and safety plans and procedures. David mentioned earlier about connectivity on site, and your key issue, if you will, with live streaming is a decent data connection to the cloud. This can be overcome with fairly standard equipment, and really just relies on a strong cell network. So that can be overcome in most locations now, and if the cell network isn't present, usually a Wi-Fi network is. So that's generally speaking how we would tackle that. So thanks, David. I'll let you continue on from now.
Thank you, Ben. So safe, accurate, cost effective. We will provide more information to people who want it. Just by the way, request that through email, and we'll provide some technical support either through Ben or through myself in terms of how we see the drones operating within your specific sector. I'm now going to hand over to Iain Hyslop, who is going to talk a little bit about where we see the sectors that benefit from drone technology.
Thanks, David. And yeah, the guys have already touched on some of the environments and sectors that drones can work in, and there are many of them. Construction and civil engineering being one. Within those two sectors, we do a lot of working at height, and crucially, we can reduce the time spent working at height. We can use the drones for survey and inspection work. They are particularly useful for remote inspections, bridge work, excavations, and confined spaces. And indeed, there's a video coming up of a drone operating in a confined space, so you'll get an understanding of the adaptability of the machine. Working adjacent to water can also be very hazardous, and again we can use the drones for survey and inspection work, and reduce the need for personnel to be close to the water's edge. Putting people close to the water's edge always involves a lot of planning and management, and again, we can reduce the time spent on that and crucially reduce the risk of people working beside water. Transport and logistics is another sector where we see drones benefiting. Ben mentioned earth moving equipment. We do not want the people-plant interface around heavy plant and equipment. And again, the drones can be used for surveying purposes and also to monitor plant vehicle movements and assess the suitability of traffic management plans. The railway is another sector that we see drones working in. We all know how hazardous track work can be. And again, we can use the drones for information gathering rather than putting people at risk on the track or trackside. We can monitor progress live during possession work, and we can also collect data from structures and other railway infrastructure. Event management is another area that we see drones bringing benefits. Large crowds need to be monitored as they are very fluid. Again, the drone can provide live information and movements and flows of people and improve safety and security. So there's also many other sectors where we could use drones. I've just given you some examples there of some of the high risk work that can be eliminated and reduced by using drones. Thanks, David.
Thank you, Ian. Very helpful. I think also what we should bear in mind in a post-COVID environment, there are a number of organisations that are correctly limiting the number of people who attend site, including safety advisors, and so people who don't need to attend site are not necessarily being asked to attend. This is where perhaps a drone may substitute. So remote inspection by having people trained in-house as pilots. We can have that electronic tethering between a health and safety professional who's not at site and an on-site drone pilot. And that could operate in many sectors. And we'll speak a little bit more about that when we talk through the technology itself. I'm going to ask Ben now to just talk us through, the difference between some of the drones that we use for external survey and inspection and some of the capabilities of that technology. There's a couple of videos in here. Hopefully they'll transmit to your laptops in good form. And we'll also talk a little bit about internal surveys. And Ben did mention this. He mentioned that there is a new type of drone that has been manufactured, which is more agile, it's smaller, it's lighter, and it's really safe for use within internal settings. We are seeing a lot more of these drones actually being used. And perhaps these drones could be used in warehouse settings, large factory shop floor settings, and that's perhaps where some of this thinking starts to need to move towards. Yeah, we do recognise there will be some constraints there, and we do recognise there will be some protocols that we need to put in place, but all of that now begins to become possible with some of the technology that started to develop within the drone world. So with that, I'm going to ask Ben to take us through internal survey and inspection, and then moving on to internal survey and inspection. Thank you, Ben.
Thanks, David. So on this specific example, I'm going to talk about a survey of a.
Ben, I think you're on mute.
Oh, okay. How's that? Is that working now, David? David?
Yeah, that's good.
Yeah. Okay. So on this, for this example, I'm going to talk about surveying an active open pit mine as a fairly dangerous environment, and it's an area where stockpile surveying and volumetric surveying is very useful. So the pit mine in question is located in Scotland. And the drone deployed was a specific survey drone, which is equipped with additional elements of technology to provide extremely high accuracy surveying data. So the way this works is you deploy the drone at a certain height. In this example, it was approximately 75 meters above the ground level of the pit mine, and the drone then flies a grid pattern above the area to be surveyed, taking a series of images, and those images are later stitched into a 3D model, which you'll see in a second, and that allows you to analyze all of the areas of the site in extremely high detail. So generally speaking, you're talking about a level of detail at about 2 centimeters per pixel of data. So it's incredibly high resolution and far higher than any other survey technique at the moment. In this case, the drone team were located off-site in a clearly marked area, and they had no need to interact with the moving machinery down on the quarry floor. The survey was actually completed within an hour, which is often very surprising. The drone itself is in the air for very little time. Occasionally, it will bring itself to land to change batteries, and then it'll go back to continue on its flight path. So you contrast this with a traditional survey technique involving personnel on site, walking around with traditional survey mast and staff, and they're often on site for several hours or even days, depending on the site size and complexity. They're going to be scrabbling over stockpiles. They're going to be trying to keep an eye on plant moving, and also operations on site are generally going to be affected, not necessarily massively, but in some way there's going to be an increased level of awareness required from all the members on site. So with this technique, it's more dangerous, but it's also less accurate. So to illustrate its accuracy, it was a short animation which will play, hopefully. And if David, if you could start that, please, thank you. So this is taken from the 3D model that was created on site. The image will move in a second, and it will show the process involved in gathering a stockpile measurement. It's not playing yet, but we're having a good time with this video as expected. There we go, that's it working now. So the measurement of a stockpile is as simple as drawing around the area you want to measure and then computing it. And this is the amount of time it takes. You see the green bar moving across the bottom, and then the readout will come up, and that gives you the volume of the material that's just been measured, and in this case, the volume of the material to the back as well. And this can be done for any area on site, and it can be done for stockpiles. It can also be done as part of cut and fill analysis, and you can also create elevation profiles, contour maps, and all these sorts of things. Anything you would expect from that data. So this is quite a specific example, and it's not necessarily going down the inspection route, but the cameras and the equipment based on these drones is very high resolution and can be used in inspection for more or less any purpose in terms of an external environment. However, generally speaking, if we were doing an inspection of say a roof or something more complicated, we would use a slightly different drone with a slightly higher resolution imaging sensor, purely to get more detail from the subject. So if you could advance to the next slide. Thank you, David. Internal survey inspection is a slightly different beast. With external drones, they are using GPS to control their location in the air. So when you starve the drone of that data and that connection, its ability to fly itself is massively reduced, as you can imagine. So internal drones behave in a very different way, and they involve a far more active pilot interface. The pilot is responsible for everything the drone does, as opposed to the slightly more straightforward external drones where you can fly straight, forward, back, whatever, but the drone is going to hover when you leave it to its own devices. In an internal environment, a strong wind, for example, can move the drone. So you have to be aware of all these sorts of things and correct accordingly. So using the latest internal inspection drones can provide a detailed overview of large and extensive shop floor or warehouse operations, or provide inspection data from the more challenging areas of your facility, such as boiler rooms, stacks, testing facilities, and confined spaces. It's capable of returning visual and thermal data, so inspection by drone provides the intelligence you need to carry out targeted asset management with accuracy and reduced risk. If we could play the next video, and I'll talk through what you're seeing, hopefully. Now, this video is unfortunately stepping a little bit, but the video itself is 4K, and the camera based on the drone can rotate up and down 390 degrees. It's fixed within a carbon fiber impact resistant cage with onboard proximity sensors, so it will avoid crashing into the side of walls, but it's also built to be able to do that and withstand that. On the front of the drone, there's lighting, which is configured in such a way as to be dust proof, so you can see in extremely dusty environments. And that lighting can also be switched on and off to provide oblique angle detection, so you can see pitting, cracks, and these sorts of things on surfaces inside of your asset. The drone is about 40 centimeters wide, so it can fit through any standard manhole. Here you can see it's struggling to fit through that bracing structure, but it does it, and that's the way it's designed, is to kind of feel its way to a certain extent. And it can safely and easily be flown into assets with no human access required. At no point do personnel need to enter the space during the inspection. Thanks, David.
Thanks, Ben. Okay, so that was a fairly good summation of external survey and inspection, along with internal survey inspection, and the two different types of drone and their capability. So I just want to put across kind of our vision for part of what we see drones and safety and how they might work together. We have got a view with some organisations that we've been speaking to that the movement of key HSEQ personnel is becoming obviously more challenging, in the post-COVID environment, but actually also just by the very nature of the work that some of our clients do. We work for a number of global organisations, and the movement of key personnel is becoming more and more challenging. So this is where drones fit rather nicely. What we see is the potential for companies to organise HSEQ professionals anywhere in the globe and effectively tether them electronically with a drone and a drone pilot at any other particular location where they happen to be operating. And if, for example, you were working for an NGO, where you were working maybe in post-conflict or other types of challenging environments, then perhaps this type of facility may also work very neatly for you. And the way that we see it is that the way we would package up this type of work is that we would have a company or organisational personnel in country trained to fly the drone. That training, incidentally, could be provided online. So the drone would be shipped to the personnel at site. That would then be followed up by a number of hours of training, such that the personnel at site can then operate the drone and fly the drone safely, and within the rules and regulations set out by the governing aviation authority, because each aviation authority will have a different set of rules for drones, as we are probably aware of. Once the pilot is trained and has the capability for external and even internal flight, we would then have the connection back to the HSEQ advisor. That HSEQ advisor could be someone, for example, from Project Health and Safety Services, or indeed it could be your own organisational advisor. And what we're trying to create this vision here is that you can have this capability 365, 24/7, anywhere on the planet, on the basis that you have this drone capability and some form of either connectivity or a recording that's then sent down the line a short time after the inspection or the survey has taken place. So we know, and we kind of get the view from our clients, that this will work and be appropriate for difficult to access regions, difficult to access countries and sites. There are specific organisations that are working, for example, within the water sector, where dams and reservoirs and that type of infrastructure may lend itself very well to this type of survey. And we know of a number of recent catastrophes that have involved dam collapse, and perhaps there may well be a requirement for enhanced survey, enhanced inspection that drones can facilitate in the future. As mentioned earlier on, we are very much viewing this as training local personnel to pilot the drones. if we were looking at this through the lens of a global approach, then certainly we would be seeing an autonomous local pilot as opposed to somebody who's has to go to site to do that. And that the best-in-class drone would be selected for the task. So again, if we were looking at an internal task in a confined space or a tank or a test facility, then we would choose the correct drone for that task. Or if it was an external drone, again, we would have the correct drone for the task. We then have the connection to the remote professional advisor, and I've mentioned earlier on that could be perhaps a project health and safety services advisor, or indeed it could be one of your own safety advisors in a remote location. We would use live link up where appropriate, where we've got the connectivity, or we would have recorded footage. And the beauty of all of this is you not only have now your inspection checklist, but you're actually getting recorded footage. So you're getting a kind of footage that goes with as a record, as an archive of the inspection to support the inspection checklist. It offers up the potential to provide real-time advice. So you may have an ongoing situation. So this might not be for an inspection. This could be for, the very rapid aftermath of an emergency situation where you need to have in-country advice on call. Again, obviously that needs to be facilitated, it needs to be set up on that basis, but there is no reason why you can't bring expertise to a site using drone technology where that's required. And for the health and safety advisors who are on this webinar, you will all, I'm sure, have experience of an emergency situation or a technical situation where, for example, you would have really liked to have had a technical expert available to you to advise. We do think that in this circumstance, drone technology can provide some of that, particularly for the larger sites where it's very, very difficult to access work at height. Prime example, perhaps it's roof work, perhaps it's a dam, as I've mentioned before, or a difficult to access part of infrastructure. That's where potentially this technology really, really works quite well. It can, as we've mentioned, and the main reason for having our webinar, the main thrust of this is the remote safety inspection response. And of course, we'd expect it to have all the usual outputs. That would be a checklist. So the remote safety advisor would be going through his normal checklist. He would be prompting the pilot, and either that prompt would be an advanced prompt to say, here are the things that we're wanting to look at. This is the shots that I want to visualize. Or they'll be doing it live as part of a live link up, where the safety advisor would be requesting that the drone pilot moves to certain locations within the site or the facility or the piece of infrastructure. And the safety advisor would probably be asking some questions in and around that, or visualizing themselves what they needed to visualize. From that, clearly would be an inspection outcome, the checklist itself with the results, and as I mentioned earlier, the footage. And that footage can be spliced and edited to provide particular aspects of what was shot that day. So if you wanted to get a very decent close-up of a particular piece of masonry on an infrastructure, then the edit or the splicing of the film could do that. So again, we could have that edited and support the inspection checklist once completed. So in summary, we are seeing this kind of model as being how we would operate this remote drone survey inspection program, where we would have a survey flight by a trained local pilot. That training can be done equally remotely. However, if you were doing more than one pilot, it may well be we need to send a trainer to site. UAV 365 could provide that support. Then obviously what we're doing is carrying out the survey. The data itself, where appropriate, can be converted to a 3D site model, such as the one that Ben illustrated earlier on in the webinar. But also, clearly what we're trying to do is use it as part of an occupational safety and health inspection designed to operate remotely. The OSH inspection, flight by the local pilot, and analysis of the data in real time or as part of a record from a previously recorded flight plan, sent to the OSH report to the site manager and converted to a document and to recorded footage that would then go on record as the inspection. So the opportunity to really get into some difficult areas, also to provide rapid, real-time support for emerging situations, bringing expertise that isn't readily available at site on a kind of global, country by country, region by region basis. So a real opportunity potentially to bring this type of technology to standard health and safety inspection. Now, during the course of this webinar, we've had a few questions. So we've got 4 or 5, which I'm just going to pick, and I'm going to ask Ben some of these questions, and then I'm going to ask Iain Hyslop to do a final summary, and that will close down our webinar for today. And if you do have some further questions, which we haven't been able to answer during this brief Q&A, then please write to us by email, drop us an email, and we'll respond to you. We will, as I say, be running some other webinars related to technology and safety, and we'll publicise them in due course. But just to talk you through some of the questions that came up, and I'll ask Ben to answer these questions if we could. So Ben, one of the questions was, how long does it take for a novice to become a drone pilot typically?
Okay, yes, so we tend to measure the experience in flight hours. So I would suggest about 30 hours of flight would take you from knowing nothing to knowing enough, if that makes sense. The trick with drone flight is preparedness, and also experience just from knowing what can go wrong, what you should be watching out for, and generally just getting used to the way that the vehicle moves in the air. So yes, I would say about 30 hours, Dave.
Okay, thank you, Ben. How much does it cost for a basic professional drone for the type of survey and inspection work we've just been looking at?
So there's quite a range of costs. If you're thinking of the model that as shown in the summary here, that's been designed around a drone of in the region of £2,000 to £2,500 pounds sterling. Then you could take it up to, for example, that internal inspection drone is a very advanced piece of kit, and that might be again locally changes, but about £30,000. So that's a slightly different order of magnitude in terms of drone technology. Internal inspection really is all about protecting the equipment and also the subject. So that's where all the advancements are in the cage, the protection around the drone, and the sensors around that as well. So yeah, quite a big range. But this particular thing has been designed between £2,000 and £2,500.
Okay, thanks for that, Ben. And from the UK, somebody asked specifically, what are the rules in the UK for flying drones commercially? What do people need to have or do?
So commercially is a fair few steps beyond the normal amateur level of drone licensing. But primarily you need a license and then a certificate and permission to operate. You also need to have a flight manual. There's a specific term for that actually, an up-to-date operations manual that would then allow you to fly commercial operations, and that then is measured with against the CAA who give you that permission, and that in turn can be expanded with something called an operational safety case, which allows you to, for example, apply for specific way leaves on the amount of distance you might be between a drone and somebody who is out with your control, and that can maybe be brought down from the standard 50 meters to maybe 30, and in many cases a little lower than that. It's with all these things, it's all about preparedness, and specifically with the CAA, in our experience, as long as you show them you are covering the bases and doing everything you can to make the flight as safe as possible, they're generally very amenable to helping you operate. It's certainly not an activity that they throw up obstacles for the sake of it.
Okay, thanks, Ben. And from a UAV 365 point of view, can you support sourcing a drone and providing training pretty much in any country? The training perhaps being done remotely?
Yes, yeah. As you said before, the preference would be to train remotely if we can avoid travel that's not necessary. But equally, sending one of our operators to site and training locally may well be the best way to go about it for a kind of a kind of blitz session, if you will. But in both cases, yes, that's no problem. And in terms of sourcing the drones, there are a couple of, in some cases, local issues to that. But again, as long as you're working with a local partner, that's not a problem either.
And last question, Ben, do drones need to be maintained?
That's a good question, actually. So part of the training will cover that as well as a lot of other things. But the maintenance program is very active with drones. You want to be before every flight. You're going to be checking everything about the machine that you're working with. It's going to be your responsibility as the pilot to make sure that everything is in order. And in that sense, it's fairly straightforward. Visual checks of the obvious bits and bobs. Again, this will be part of the training. And then if there's anything more advanced that you're not sure about, you can always reach out to us, and we would be happy to help with that.
Thanks, Ben. Appreciate it. So I'm just going to ask Iain Hyslop to say a few words to summarise what we've been talking about today. But in advance of that, I'd like to thank everybody who attended today's webinar. As I said, we will publish and publicise some further webinars related to tech and other scenarios. If you want to find out a bit more about today's webinar, then feel free to contact anyone on this list here. So Iain himself, myself, David Lamont, Ben Williams at UAV 365, and our partner Adele Lawson from Moura Lawson in Qatar. But with that, I will ask Iain Hyslop to just kind of close today's webinar with a little summary of what we've been talking about. Thank you all very much for your attendance.
Thanks, David and Ben. Very interesting, very useful webinar from a health and safety professional's perspective. For me, one of the main benefits of drone use is eliminating and reducing the need for people to be in hazardous environments, and I think we've demonstrated that today. As you all know, that sits at the top of the hierarchy for risk management. And if you look at that in a practical context, why would you build a scaffold and the risk involved in that, or indeed hire a mobile elevating working platform, a MUP, when you can use a drone to gather pre-start information and other details. When you look at the MUP in particular, you may need to implement traffic management, public demarcation, and of course you've also got the transport cost of getting that MUP to site, and then operating it. The drone can eliminate many of those costs and management aspects, and of course reduce the impact on the environment as well. Another benefit that I particularly like is the ability for the drone to gather high quality information that can be used for detailed planning, costing, and then sharing that information with other stakeholders. Essentially, we're reducing the chance of unknowns throughout the duration of the project. David touched on remote inspections, particularly around the situation we find ourselves in at the moment with COVID-19, and I think that could be critical, as that's giving you're at least getting some assurance that your activities are compliant. So again, just like to thank David and Ben for their contributions, and as David mentioned, you can contact any of us at the email addresses on the screen there. So thank you very much and good day.